All right, let's talk about one of the greatest things humanity has ever done, and why some people think it never happened at all. Yeah, we're going to the moon.
Just try to imagine it. It's July 20th, 1969. The whole world is glued to their TV sets, and then you hear those crackly, iconic words. That's one small step for man, one giant leap for mankind. I mean, what a moment. An unbelievable achievement for every single one of us. But here's something wild you might not know. While the entire planet was celebrating, inside that tiny lander, a tiny disaster had just happened. A little plastic switch, the one switch they needed to fire up the engine to get home, had just been snapped off. They were, for all intents and purposes, stranded.
So you have this incredible, documented, life or death drama playing out in real time. But even with all that, a surprising number of people believe the whole thing was a giant hoax. It's one of history's most persistent questions. Did we really go to the moon? Well, today we're going to separate the facts from the fiction.
To really get to the bottom of this, we've got to rewind. Because the story of the moon landing doesn't actually start with science. Nope, it starts with a rivalry, a competition, a Cold War. And for a long time, America was losing. Badly. In 1957, the Soviets launched Sputnik, the first satellite. That sent a literal shockwave across the US. Then, just a few years later, they put the first human, Yuri Gagarin, into space. It was one blow after another, and America was seriously scrambling to catch up.
So what do you do when you're behind? You make a bold move. A really bold move. And that's exactly what President Kennedy did. He basically drew a line in the sand and told the world, we're going to the moon, and we're going to do it before this decade is out. It was this incredible, almost impossible promise. And just like that, the race was in overdrive. Now, making a promise like that is one thing. Actually doing it, that's a whole other ballgame. This was a monumental effort, a true journey to make the impossible possible. So let's look at the key players here. You've got your crew, Armstrong and Aldrin, the guys who would actually walk on the moon. And then there's Michael Collins, the man with arguably the loneliest job in history, orbiting the moon all by himself in their only ride home. And the vehicle to get them there? The Saturn V rocket. We're talking the biggest, most powerful machine humanity has ever built. An absolute beast. So picture this. They are moments away from landing. This is it, the culmination of everything. And suddenly, alarms start screaming in the cockpit. 1201, 1202. They have no idea what these codes mean. Their guidance computer is freaking out, and they are hundreds of thousands of kilometers from anyone who can help.
And if that wasn't bad enough, Armstrong looks out the window and realizes the autopilot is taking them right into a crater full of massive boulders. A death trap. So he has to grab the stick, take manual control, and fly this thing by hand, hunting for a safe place to land, all while the fuel is just disappearing. They're down to a critical 5%. Meanwhile, back in Houston, it's controlled chaos. They have seconds to make a call, abort the mission, or trust their math. They decided to trust their engineers. The call goes out, we're go. Can you even imagine the tension in that room? And then, silence. Followed by those famous, unbelievably calm words from Armstrong, "Tranquility Base here, the Eagle has landed." They made it, with literally seconds of fuel to spare. The whole world could finally breathe again. But here's the crazy part. The very evidence they brought back, the photos and videos, that's the stuff that would fuel the doubts for decades to come. All right, so let's get into it. Let's look at the biggest conspiracy claims head on and see what's really going on. Okay, claim number one, the flag. This is the big one, right? You've all seen the footage. It looks like it's flittering in the wind. But there's no wind on the moon. So what gives? Well, it's actually some pretty clever engineering. NASA knew a regular flag would just hang there limply, so they built a horizontal bar into the top to hold it out. The thing is, the bar got jammed and didn't extend all the way, and that's what gives it that crinkled, wavy look. As for the fluttering, that's just the flag moving after the astronauts twisted it into the ground. See, here on Earth, air resistance stops that motion almost instantly. But in a vacuum, it's just going to keep wiggling for a bit. Basic physics. Next up, the stars. Or, I guess, the lack of them. Why aren't there any stars in the pictures? If you're on the moon, shouldn't the sky be packed with them? It's a fair question. It does kind of look like a movie set. This one's all about photography 101. The moon's surface during its day is incredibly bright, and so are those big white spacesuits. So to get a good picture of the astronauts, the camera settings had to be for a very bright scene, a really fast shutter speed. It's just like trying to take a picture of a friend under a bright streetlight at night. Your camera will expose for your friend, and the faint stars in the background, they're just not going to show up. Same exact principle.
Okay, let's talk shadows. This is a classic gotcha for the skeptics. They point out that the shadows in the photos aren't all going in the same direction, and if the sun is the only light source, they should be parallel, right? So it must be studio lighting. But here's what they're missing. The sun was the one big light source, like a giant spotlight. But the moon's surface itself, all that bright gray dust and rock, was acting like a massive bumpy reflector. It was bouncing sunlight everywhere. That reflected light fills in some shadows and creates all these weird angles, especially when you factor in the hills and craters. So yeah, there kind of was a second light source, the ground they were standing on. So while people on Earth would later debate photos, Armstrong and Aldrin had a much, much bigger problem. Remember that broken switch? The one they needed to ignite the engine and get home? They were well and truly stuck. So what did they do? In a moment of pure genius, Buzz Aldrin looks at the little hole where the switch was, pulls out his felt-tip pen, and jams it in there to complete the circuit. And you know what? It worked. A simple pen literally saved the Apollo 11 mission. You just can't make this stuff up.
So they made it back as heroes. But the story doesn't end there. The legacy of the Apollo program is huge, and it's complicated.
First off, let's talk about the cost. This whole program was astronomically expensive. We're talking $24 billion back in the 70s, which is way over $100 billion in today's money. And a lot of people were rightly asking, couldn't we have spent that money better down here on Earth?
But here's the twist. All that spending had a side effect that changed everything. To build the little computers that guided the spacecraft, NASA needed to buy something new called an integrated circuit, basically a microchip. And they bought so many that it kick-started the entire industry, making them cheap and reliable. The very device you're watching this on right now, you can trace its family tree right back to the Apollo program. So, in a way, that massive investment paid for itself 1,000,000 times over. You know, after the last Apollo mission in 1972, we just stopped going. For over 50 years, the moon has been quiet. But that's about to change. NASA's new Artemis program is gearing up to send people back, including the first woman and the first person of color. Which leaves us with a pretty big question, doesn't it? After all this time, what new truths, what new discoveries, and what new understanding of our universe will we find when we finally return?